Today we're going to be talking about how to simplify combinations of vectors. Really all we're going to be doing in this particular video is vector addition. And we've been given this figure here with 4 different points identified in the figure. So this corner of our figure here is point A, we have point D, C, and point B here, and these different lines connecting each of our points in the figure. We have been asked to add together these different vectors. So if you imagine here the vector AB, which means the vector that starts at A, has an initial point of A, and a terminal point of B. So essentially we have the vector that goes from A to B like this would be the vector AB. We want to add to that the vector BC, which has an initial point of B and a terminal point of C, starts at B, and goes to C like this. So we have these two vectors. What's the result if we add these two vectors together? And this is, again, just simple vector addition. Well, what we need to realize is that when it comes to vector addition, we can use what's called the definition of vector addition, or more simply put, the triangle law, which tells us that if we have two vectors, we have this one vector here that's identified as u, and another vector identified as v. If we add these two vectors together, if we want to find u plus v, the triangle law tells us that u plus v is just the vector that starts at the initial point of u and ends at the terminal point of v. And this should kind of make intuitive sense to us, because if you imagine you're starting here, right, at the beginning of u, the initial point of u, and u ends at this terminal point here, you go to here, and then from this point you start at the initial point of v and you come here. Really all we're interested in is our beginning point, our very first initial point, and our very last terminal point. Essentially, we just want to get from the beginning to the end. And it doesn't matter where we stop along the way. We want to go from the very beginning to the very end, and that's u plus v. That's what vector addition gives us. You can think about it the same way you would think about booking a plane ticket. For example, if I live in San Francisco, and let's pretend this is San Francisco right here, if you can imagine a map of the United States. If I live in San Francisco and I want to take a plane and go to Denver, maybe I have family in Denver and I want to visit, so we'll put Denver like this. I want to go from San Francisco to Denver. So I go look at plane tickets, and I can't find a direct flight from San Francisco to Denver. I can't go there directly. The only way I can get there is to stop and change planes in Seattle. So let's say that this is Seattle, Washington up here. I have to go first from San Francisco to Seattle, get off my plane, change planes, and then fly from Seattle to Denver. Well, that's great, but really all I care about is the fact that I started in San Francisco and I got to Denver. San Francisco was my very beginning point, and Denver was my ending point. No matter how I get there, this is what I care about, San Francisco to Denver. So what I'm concerned with is my initial point here and my end point here. So when it comes to vector addition, here's what we can say. We have the vector A to B, and we drew that here, A to B right here. We want to add to that the vector B to C, this vector here. Really all we care about though is the fact that we started at A at the beginning, we went to B, and then we did B to C, we went from B to C. So in other words, we went from A to C. A was our first initial point, and C was our last ending point. So when we add these vectors together, what we get is the vector A to C. In other words, what we get is San Francisco to Denver. Our end result is San Francisco to Denver, or in the case of this figure, A to C. Another way to think about that mathematically, one trick I like to use, notice here we have the vector AB plus the vector BC. Well, B is this common midpoint of the vectors. If we just cancel this common point here, what we see is that we're going from A directly to C, and we skip this stop, right? The stop and change planes at B. We skip that step, we go directly from A to C. So that's another way to look at it quickly. Now, what about this? The vector CD, so if I have the vector here, CD, I go from C to D, and then I add to that the vector from D to B, so from D to B like this, what's my end result? Well, I started at C at the very beginning and I ended up at B. So my resulting vector, when I add these vectors together, is just C to B. I went from C to B beginning to end. So C to B, and if we look at this again, what we can see is that we stopped at D, we stopped and changed planes at D, but essentially we went from C to B, these two letters here that are left over. Now what happens when I have the difference between two vectors? I have the vector dB minus the vector AB. How do I deal with the difference between vectors as opposed to the sum of two vectors? Well, what I can do, instead of worrying about leaving this as a minus sign, I can convert this problem to be an addition problem instead of a subtraction problem. And the way that I do that, this vector that I'm subtracting, I just turn it around and add it instead. So this problem becomes the vector dB plus, instead of AB, I'm going to say plus BA. So I just flip it backwards, and now I can say plus instead of minus. What I see then is that I'm going from D to B, I'm stopping and changing planes at B, and then I'm going from B to A. So my result here is just the vector D to A directly, right? That's my end result, D to A. Now, if I add three vectors together, same thing here, I'm just changing planes twice, right? I go from D to C, I stop and change planes at C, and then I fly to A. Well, I don't care that I stopped and changed planes at C. I just went from D to A. So you can consolidate these first two and essentially say dA. Now I have just dA, that's the result of these two when I cancel the C out, dA plus AB. Well, I start at D, I go to A, I stop and change planes at A. I can just cancel those out, and essentially I'm going from D to B. So my result here is the vector dB. Starting at D and going to B is the result of the addition of these three vectors. So that's how you can take vector addition problems and simplify them. And if you ever get confused about this cancellation, just draw a couple different points on your paper and label them A, B, C, D, and follow this path, D to C, and then C to A, and then A to B, and think about your end result. It really is just, as long as you have addition, this beginning point here, D, to this ending point here, B, and we have D to B, versus the beginning point here, A, the ending point, C, everything except where we canceled here, where we stopped and changed planes. We went from A to C. Same thing here, beginning at C, ending at B. The result was the vector CB.